morning, students. So next we are going to discussing about the another type of sequential statement that we are using within the process. So that is loop statement. So this is the next type that we are going to discuss, another sequential statement. So first we will discuss about the syntax of that particular loop statement. Okay, how the syntax seems to be. So while coming for this, loop statement starts with a keyword loop. Okay, then after that we are supposed to write the sequential statement. So based upon functionality, it consists of either single sequential statement or multiple sequential statements. Okay, it based on the functionality. It starts with a keyword loop. Then after that we are supposed to write the sequential statements, and finally we are supposed to end that particular loop by means of using the keyword end loop. So this is how the syntax seems to be for loop statement. So it is a sequential statement. As I said previously, sequential statements we are going to use within the process. By means of combining multiple sequential, you can able to call process as a single concurrent statement. So because of that, so this is what the syntax for the loop statement. And this loop statement is, so this one is infinite loop actually. Okay, that is, so infinite times this particular loop is going to rotate. That is because of here we didn't mention any condition that how many times that loop needs to rotate. Okay, how many iterations it needs to perform, that we didn't mention. Okay, so because of that, after starting this particular loop, all these sequential statements, once if it completed all these sequential statements, then once again that particular loop, it is going to rotate infinite number of times. So because of there is no termination condition for that particular loop, in that regard we can call this particular one as infinite loop. Then where we can able to use such type of loop statements means while considering for the digital circuits. Anyway, we are supposed to apply the clock signals. So we need to apply that particular clock signal throughout the operation of this circuit. Okay, throughout the operation of this circuit, we are supposed to describe the clock functionality. We are supposed to generate the clock pulses. So in such cases, by means of using loop, we can able to generate the clock pulses. So in such application, we can go for this particular infinite loop because of there is no termination condition. So infinite number of times, okay, this loop is going to execute. So that is the first thing you need to know regarding this particular loop. Under that particular loop itself, another familiar type of loop is for loop. Okay, so the syntax seems to be, so all are same except this particular one. So if you look at this particular loop sequential statement and loop, here also loop sequential statement and loop. But in addition to that, some more. Okay, so keywords and user defined identifier we are supposed to add in front to get the for loop from the loop statement. Okay, anyway this particular for loop is a finite loop. So it depends on the range whatever mentioned over here. So because of that, while coming for this particular one, so this is a for loop. Now we are going to discussing about the for loop syntax, how it seems to be, that particular for loop. This is also another sequential statement. Okay, if you look at this particular one, the syntax somewhat seems to be, we already discussed the for loop. So in the structural description style, there also seems to be same for identifier in range, all these are except this particular one. Okay, anyway they are concurrent statements. Here we are supposed to consider this particular statements. Other than that, it seems to be same. Explanation for this particular one also same as whatever we discussed in structural itself. Okay, so we look at, so while coming for loop, it starts with a keyword for. Okay, next after that we define the identifier. Okay, where identifier is an user defined variable. Okay, and this particular variable, there is no need to mention what is the type of that particular variable it belongs to. Okay, that is because of while coming for identifier, here the type of that particular variable will be assigned from this particular range. So whatever type of range values that we described within that particular range, based on that range type, that type will be assigned to this particular identifier. That is nothing but user defined variable. So explicitly there is no need to declare what is the type of this particular user defined variable, but implicitly it was declared same type as whatever the range type it consists of. Okay, so that is the thing. So in that regard, okay, explicitly, so there is no need to declare that particular variable. Let it be, for example, I am considering identifier as B. So user defined variable, anyone you can able to consider. Here I assumed it as B. Then while coming for range, here I mentioned for example 1 to 4. So because of that, while coming for this particular identifier, here I mentioned it as B. So implicitly it declared a type of, because here it mentioned 1 to 4, where that values are a type of integer. So in that regard, this B also implicitly declared as a type of integer. But no need to mention explicitly. Specifically there is no need to mention this particular B belongs to integer type. Implicitly it declared to same type as whatever range, okay, type it consists of. Here B identifier, range I mentioned 1 to 4. So because of that 1 to 4 it comes under integer type. So because of that this B implicitly declared it as an integer type. And also while we are mentioning sequential statements, we can also able to use this particular variable within that particular sequential statements. And how this particular one is going to execute means, so based upon the range. That too, while we are reading values from that particular range, we are supposed to start from left to right, starting from 1 to 4. So because of that, whenever loop gets started, so first this identifier B is going to get a value of 1. Okay, so by means of that these sequential statements are going to execute. And next B moves to the next one, loop. So because of increment by 1, by default we are going to indicate next B value are going to get a value of 2. So that is the second iteration by means of having B equals to 2. And third one is assign B to 3. So third iteration, and finally fourth iteration. So based on that, if I mention 1 to 4, total this particular loop is going to repeat 4 times. 4 iterations needs to be occurred if I mention 1 to 4, starting from left to right, that to that range. Range always we are supposed to consider from left to right. Because of that, first initially for B1, then keep on increasing 2, 3, 4. Once if it reaches 4, then it is going to terminate that particular for loop. So that is how it is going to execute. So syntax, for is keyword, then identifier, any user defined variable you can able to describe, but no need to mention what is the type it belongs to. And in is a keyword, then range. Range, so as per here mentioned 1 to 4 or 4 to 1, whatever it may be, range you can able to describe over there. Then loop is a keyword. Then after that sequential statement, based on application, once again either single statement or multiple statements you can able to describe over here. Then after writing of that particular one, we are supposed to close that particular for loop by means of considering the end loop keyword. Okay, so coming to this particular one, after 4 iterations, starting from 1, 2, 3, 4, after 4 iterations, so it is going to terminate this particular for loop. So because of that, here we mentioned, so what is the termination condition for that particular for loop. But if you look at this particular one, there is no condition we described over there. So because of that, this comes under infinite loop. Infinite number of times it is going to, okay, rotate, okay, execute, while coming for this particular one based upon the range. Okay, in this particular case 4 times. So this sequential statement keep on executing 4 times, 4 iterations it needs to perform. Okay, so that is what regarding the syntax for the for loop statement. So this is how it seems to be. For identifier in range loop, sequential statement, then end loop. Okay, so now considering this particular one, and 2 more important sequential statements that we have. So those 2 are exit and next. Okay, these 2 also very important. So these 2 comes under another type of sequential statements that we are using, so within the VHDL. Okay, those 2 are One is exit, second one is next. So what is the difference between those two? Anyway, this particular part is whatever I described previously, same points. While coming for this exit and next. So what is the difference between them? So while coming for exit, whenever this statement is occurred, then automatically compiler control goes to the immediate statement whatever we described after the end loop. That means whenever exit is going to occur, it terminates that particular loop. Okay, even though remaining iterations are there, let be in the previous case I mentioned B 1 2 4. Let be B 1 value 1 iteration, B 2 value 1 iteration. After second iteration, so if the compiler faces that particular exit statement, then obviously suspending remaining 2, B equals to 3, B equals to 4. Suspending remaining 2 iterations, directly the control goes to the immediate statement of that particular end loop. After end loop, whatever statement we described, so control goes to that particular statement. So that is what exit. Okay, so immediately exit control to the transfer controls to the statement immediately following the loop end. So that is what exit. So what it performs means. Then while coming for next, so considering of that particular one, so it is going to bypass the whatever statements, still it needs to execute in that particular iteration and it starts the next iteration. Let be same as in previous case. So B equals to 2, that iteration is going on. Okay, so it consists of 10 statements. After executing 5 statements, so then if it faces that particular, it needs to execute that particular next statement, means it is going to skip remaining 5 statements within that particular iteration and control goes to the next iteration where B equals to 3. Okay, so that's what next is going to perform. It is only terminating that particular iteration, but so it's moving to the next iteration. But while coming for exit, it closes that particular loop, and control goes to the next statement whatever we mentioned immediately after the end loop. It terminates the loop, it only terminates that particular iteration and it starts the next iteration by means of bypassing the remaining statements whatever present in that particular iteration. Bypassing that, control goes to the next iteration, but it is not going to terminate that particular loop statement. So that's what here we described. So next causes any remaining statements in the loop be bypassed and begins the next iteration of the loop. So that is what the main difference between exit and next. While coming for exit, it terminates that particular loop. While coming for next, it only bypasses the remaining statement in the current iteration and starts the next iteration in that particular loop. So that is the main difference between exit and next. Then based on considering all these sequential statements, next we would like to write a program in behavioral description by means of using all those sequential statements whatever we discussed till now. That means loop, for loop and all. Anyway, to realize this particular one, we are supposed to consider the for loop. Here once again, so we consider the prime number detector. So by means of using for loops, even for law circuit also in a simple way we can able to write to describe that particular one only. Here I considered the 16-bit input prime number detector. So previously we discussed about the 4 input prime number detector, but here we consider the 16 inputs. 16 input prime number detector. So considering of that particular one, so first starts with the keyword entity, because of previously we described entity for only for 4 input prime number detector only, but here we consider the 16 input. So we are supposed to change the entity as well. In that regard only, here I also described the entity part in addition to architecture definition. Even though that much complexity, 16-bit means it seems to be very complex, that particular circuit. Even that much complex circuits also in an easy way you can able to describe by means of using for loop. That is what I would like to show to all of you. So because of that reason only we consider this particular one. Anyway, that entity declaration part starts with the keyword entity. Entity name is, then port. here n value is previously 4 bit, because of that 3 down to 0, okay, or 0 to 3 we considered, but here array size is increased to 16, so because of that 15 down to 0. So this particular one consists of 16 inputs. Then while coming for output, anyway output is single output. If it is prime means that circuit needs to generate output as 1. If it is not prime, the given input, then that particular output needs to generate output as 0. So that is what the functionality. So in that regard output F, which is equals to a single value. So in that regard F out std underscore logic. Then we are supposed to close the entity part by means of considering the end entity name. So that is what. With that we completed the entity part, and also you must describe the library and package before that particular entity declaration part. Don't forget it. Anyway, those two statements are common. So in that regard only we didn't consider that particular library and package declarations, but entity part is going to differentiate, because of here we consider this 16-bit input, not 4-bit input. Okay, that's why once again we described that particular entity part over here. But before that you must describe the libraries and packages. Okay, anyway, so after completion of entity declaration part, next we are supposed to start the architecture definition. It starts with a keyword architecture. Architecture name of entity name is, then begin. Then within architecture body we are supposed to write the concurrent statement. Anyway, in behavioral the concurrent statement that we are using is process statement, where process consists of multiple sequential statements. Combining all those, you can able to consider it as a single concurrent statement. So because of that, so after begin, the concurrent statement that we considered is process, because of it belongs to behavioral. Okay, so process of anyway sensitivity list, nothing but inputs itself we are going to describe n, but here n is 16-bit array elements it consists of. Remember it, not 4. Here we described 15 down to 0, because of that where it consists of 16 inputs. Remember that particular one. And next, so here, so as per requirement of our functionality, here I described two variables, because so these ni and prime, so I am using only within the process. So previously I didn't define. To achieve the functionality only I defined within this particular process. So in that regard, okay, I supposed to describe them as variable itself. Okay, so for that reason here I consider two temporary variables. So these two are required to perform the operation. In that regard only we generated two variables. While coming for this, first variable is ni. Okay, so where we mentioned that particular type as integer, and next variable is prime, and that type as boolean. Why I consider these two variable means, anyway this particular circuit consists of 16 inputs. Then while you are writing program, if you write in binary form means 2 power 16 combinations we are supposed to cover, and also within double quotes we are supposed to put all these 16 bits. It seems to be very difficult to write a program. Okay, for 4 bits only it seems to be somewhat difficult, while coming for 16 bit means 16 bits you are supposed to type within the double quotes. It seems to be very complex. So in that regard, to reduce that particular complexity, here what we are doing is by means of calling the function. We are, as we already mentioned, okay, so we already, okay, we may think that so we can think that so as per okay, so here our intention is, so here so while coming for why I mentioned these two as variables is, so based on requirement, while coming for that the idea is, first instead of writing those binary data, so once if I can able to convert that particular binary form into integer, then it seems to be easy. So because of 16-bit length seems to be difficult, so instead of that if I mentioned in integer values means, so the program seems to be very easy. So in that regard I consider this particular one. Okay, so integer, and next to that boolean, because by means of verifying this particular temporary variable, finally I am going to mention f value is 0 or 1. Okay, initially because of boolean I assigned the type for that. So boolean having two values, one is true, another one is false. Okay, so temporary variable prime that I considered by means of assigning a type of boolean. Initially I am going to assign that value as a true, and based upon the realization, so finally I am going to store either true or false within this particular prime, and finally while assigning value for the output f, I am going to verify this particular prime, temporary variable. If it consists of true, then obviously f needs to get a value of 1, and if prime becomes false, then f need to be assigned a value of 0. So that is the logic we are supposed to consider over here. So here what is the logic we followed is, first we are going to convert binary into integer. Then using of that particular integer, writing of this particular program seems to be easy. That is the first step I am going to perform by means of using the function. As we already mentioned in the previous classes, so we assume that one function is there where it can able to convert string_like_vector into an integer. Same function I am going to call, and that integer value I am going to store within this particular temporary variable. Then after that, here we are going to describe the prime as boolean, and that boolean, so boolean nothing but two values, true or false. This prime, verifying this particular prime itself, we are going to assign the value for the output here. So consider, because of that I considered these two variables. Then after that, process body begins with a keyword begin. So what is the first statement? Here I call that particular function which is convert integer of n. So what it needs to perform? So it is going to convert whatever input binary form we applied as input, that will be converted into integer, and that integer value will be assigned to ni. Because of that reason only here we assign that particular one as integer. After that, so next consider another variable which is prime. So prime I assigned a value of true. Because of prime I mentioned boolean, I can able to assign any one of the values which is true or false. So here I assigned a value of true. Because of these two, ni and prime are variables, the assigning operator must be colon equals to. While coming for signal, less than or equals to. Remember that particular one. Whenever we are assigning value for variables, we are supposed to use the colon equals to is the operator, assigning operator. So initially I considered prime as true. Now, so we need to start the program. So if first I considered if, that is one type of sequential statement. If ni is 1 or ni is 2, by default we know that 1 and 2 both are primes. So in that regard, then null. Null nothing but it returns nothing. If ni equals to 1 or ni equals to 2, if any of these two values, so if we applied at the input side, then it do nothing, that particular program. That means whatever data so we mentioned in those variables, that remains as it is. Whatever we mentioned, so within prime we mentioned true, that remains unchanged. That's what going to happen by means of considering a statement which is null. Null nothing but it returns nothing. So that's what. So here null. That means whatever we mentioned prime, so that will be stayed as it is. That means prime becomes true itself. Then after that, else. If I applied other than 1 and 2, then control comes to this particular else part. Then within this, here we consider the for loop. For identifier, here we considered identifier nothing but user defined variable. Here we described it as I. Then in is a keyword. Then here we are supposed to represent the range. Anyway, 1 we should not consider. So because so value will be divisible by 1. So in that regard we should not consider 1, because so how we can able to say a number is a prime number means it needs to be only having 2 factors. That number need to have only 2 factors. One is 1, another one is that number itself. If that particular one having only those 2 factors, then we can able to say that particular one is a prime number. So here we considered, so because of that 1 we didn't consider, we started that particular loop with 2. Then 2 to 253. Certain number they considered. Then it starts the loop. So loop if ni mod I, because of we are supposed to verify the reminders. Whatever value mentioned by that, so that must be divided by all these from 2 to 253 based on loop. So ni mod I. So where mod functionality is, it is going to generate the reminder. So if reminder we got a value of 0, then obviously we can able to say, so that is not belong, that number is not a prime number. And also one more condition we are supposed to verify, that particular number, okay, whatever input we applied, so that should not be equals to I. Because as I mentioned previously, so prime number having only two factors. So one is that number itself and second one is, okay, 1. So in that regard, by means of this I eliminated that particular one. Second one I am supposed to eliminate is, so that number itself. So by means of this particular condition I am eliminating that particular factor as well. So ni not equals to I. Then, so if I got mod value as 0 and in addition to that, so this should not be equal. If these two cases are true, then so prime become false. Because if you got remainder means, then obviously it's not a prime. Okay, and also, okay, two cases we got. One is whenever we divided with 1, second one is with that number. So here I eliminated that particular one. Here by means of mentioning this, I eliminated the situation where it is going to divide with that particular number. So because of that, so with remaining numbers only we are supposed to divide it. So for that case, if this particular one becomes true, then obviously it's not a prime number. Because of that, right now prime we are assigning of false. Previously we assigned prime as true, but here if this condition is true, so if you got remainder as 0, then obviously prime will be assigned with a value of false. Then once if you got this particular whatever number we are dividing, that particular one is not a prime, then no need to perform any other additional loops. So in that regard we are supposed to exit from that particular loop. For that reason here we mention exit. Okay, and after that we are supposed to close the if statement. So with end if. This if we close it over here. After that we are supposed to end that particular loop with end loop. Then after that we are supposed to close this particular if because of that end if. Then after that, okay, with that up to this particular if we so close it. Next we are supposed to consider this particular begin. Then considering this particular prime, so whatever value stored, if prime, okay, if prime, if it is true means then f assigned a value of 1. If prime having a value of false, then f assigned a value of 0. Then we are supposed to close this particular if, that is end if. Then after that, so we didn't close this particular process. For process this begin is there, that must be closed because of that end process. Then after that, here also one more begin for the architecture, that also must terminate by means of using the end architecture name. So this is how to write the program for that.